Okay, good day, learners. Godfrey is here again. Um, Today I want to look at the topics that we look at in term one. In term one, we look at climatology, and we focus on topics like mid-latitude cyclone, tropical cyclone, anticyclones, and so on and so forth. So for the focus of today, I want us to look at mid-latitude cyclone and just a few aspects that I'm going to remind you. I know I've done this before, but I'm going to remind you of some aspects before I proceed. And in this process, I'm going to do this while I am giving you some kind of questions. So we shall do it in form of question format. But what I'm going to do, I'm just going to remind you a few aspects, and I'll just outline them here. First of all, in this case, we need to know what, when you talk about what, we are referring to the definition now, the definition of mid-latitude cyclone. So we start with what, okay, where, when, okay, and then we can also ask or answer why, okay. So in this case, when we say what, if we are referring to mid-latitude cyclone, we define it and we say it's a low pressure system, as you know it very well, the low pressure system, that is influenced by the polar easteries, and the subtropical westerlies. So when you look at these two winds, these are very important. Where do they occur? They occur at the subpolar front or at the subpolar low, and it results into the formation of the polar front. Okay. So by looking at this, we ask, what is it? Okay? And by you understanding what is it, then we're looking at a definition. Where does it occur? Then we all know that it occurs between 30 to 60 degrees latitudinally, that is north and south of the equator. Okay, it occurs between 30 and 60 degrees, both north and south of the equator. And this is where we have the Ferrel cell. Okay, when does it occur? We know that a mid-latitude cyclone occurs throughout the year, okay, throughout the year, but it affects South Africa, it affects SA only during winter time, okay, it's only during winter time. So there we have answered, when does it occur? And why is it occurred, or why is it affecting South Africa during winter time? We know that in this case, we look at the fact that the ITCZ moves with the apparent movement of the sun. And you know that when the ITCZ moves further north, it simply means that it will be winter in the south. Okay? And that means because the MLCs or the anticyclone, they move with the ITCZ, that means it will move also further north in order to move with the ITCZ. And as that happens, that is when it will be affecting South Africa. And you know that you looked at the characteristics of mid-latitude cyclone, aspects like it occurs in families, you know, we talk about its movement and we say it moves from west to east. In other words, it is eastward movement. And we also know that mid-latitude cyclone, it occurs in series. Those are families. We also know that mid-latitude cyclone is influenced by those two air masses, the polar front, the polar easterlies and the subtropical westerlies. Okay. Then we also know that it has got the cold sector, it has warm sector, yeah, and so on and so forth. There are a lot of characteristics that we need to look at. Okay, this is just a reminder. Remember, I said that I need to remind you of these aspects before we proceed to looking at our questions. So you also remember that you must have looked at the conditions that are necessary for the formation of tropical cyclone. First of all, we have what we call temperature differences. Temperature differences, you know very well that these temperature differences is also in the air masses. Okay, remember, one air mass is cold, another air mass is warm. So the polar easterlies is the cold air mass, and the subtropical westerlies is the warm air mass. That is one condition. And we also know that there must be the existence of the high pressure. Remember, when you look at its area of formation, we have high pressure in the north, also have high pressure somewhere there. This way, we have the subtropical high, and we also have the polar high and the subtropical high. So we know about the high pressure, that in the high pressure, air rotates anti-clockwise, okay? And then we also know that in the high pressure, air diverges onto the surface of the earth, meaning to say, if it diverges from the other side, and this one is also diverging from this other side, it will be in position to meet where? It will be in position to meet here at the subpolar low, which we know as the polar front. And because they are moving in different direction, it starts what we call the initial stage. Okay, so we looked at those conditions. We looked at the effect of a tropical cyclone on the environment, on people, and so on and so forth. So having seen all that, okay, and having reminded ourselves of those aspects, now we need to proceed and look at the questions that we have here, okay? We need to proceed and look at the questions that we have here. I told you that I've told this several times. So now I want us to make sure that we learn how we can handle different questions and how can we answer those different questions that might come on our way. So I got this question from one of the past papers in the previous years, okay? And this question is in form of a synoptic weather map that is related to a mid-latitude cyclone. When you look at it, remember in geography, when you're given a question, you don't need to rush and look at the questions that are given. You need to look at the diagram first, which we know as the annexure. Thereafter, you might find that by interpreting the diagram very well or the annexure very well, you might be answering some questions indirectly. So by the time you reach the questions, you already know what is about the diagram. So here we look at the mid-latitude cyclone, and here we have South Africa, okay? So we have South Africa here. There is a low pressure here at the coast, and I think learners, you haven't maybe looked at this clearly, or you haven't reached there, but it's called a coastal low because it is at the coast. Okay, then we have a cold front here, and we have got a warm front there. So we have got a low pressure that is well developed here, which is below 992 hectopascal. Then they have given us the date. You can see 25 of August 2020. Okay. Now, when you look at this, there's a high pressure here, and this one is appearing like that. So what we need to do, we need to look at now the kind of questions that are being asked. Okay. When you check your question, they say, figure 1.3 shows mid-latitude cyclone on a synoptic weather map of South Africa. Then you come here, you can see it's a mid-latitude cyclone because of the cold front and the warm front that is visible there, and it is moving from this side to the side, and it is approaching Western Cape. Okay, so it's a cold front that is affecting South Africa. Like I told you that you can already see the sketch of South Africa. The first question that comes our way is saying, Okay. The first question that we have on our way is saying, give evidence from the diagram. Give evidence from the diagram. You can see the questions. I want to read it as many times as possible so that you can understand what the question requires. Okay. They say, give evidence from the diagram that suggests that weather system A is a mid-latitude cyclone. What evidence do we have that suggests that weather system A is a mid-latitude cyclone? We go back to the system. The system is here. What evidence do you see from here? A is here. And there's a cold front here, there is a warm front. What evidence do you see that this is really a mid-latitude cyclone? Hope you understand. You can see learners here. So you can see the cold front. Can you see it? This is a cold front. Okay. And the moment we talk about mid-latitude cyclone, automatically what should come in your head is a cold front and a warm front. So the first evidence that we have here is that the cold front and there is a warm front here. You can see the symbols. It's a cold front and a warm front. Therefore, that is evidence number one. So evidence number one is that cold front and warm front are clearly visible. That is evidence number one. You can easily see the cold front and the warm front. Okay? That is evidence number one. Evidence number two. When you look at this line here, can you see on this line, we have got this symbol here and this symbol, which tells us, obviously, that this low pressure has reached its occlusion stage. And when you remember, if you remember from your books, we talked about the stages of development, and we mentioned that the first stage is the initial stage. Second stage is what? The development stage, okay, or the wave stage. Then we also have the mature stage, okay. We also have the occlusion stage, okay, occlusion stage. Then you also have the dissipating stage, okay. And when you talk about the stages, initial stage, you know that air is just moving in the opposite direction. Development stage, a wave develops, okay, and a kink starts to come up, okay. That is development stage. Then you know that when you talk about mature stage, clearly the cold front and the warm front can be clearly visible. When we talk about occlusion stage, you remember that the two symbols of the cold and the warm front appears on the same line. Why is it so? It's because the cold front or the cold air moves faster than the warm air, and it catches up with the cold front, which catches up with the warm front, which results into the development of the occlusion stage. And the dissipating stage, you know that the pressure starts to go high. So the moment you remember that, you will see that somewhere here, if you can see it clearly, somewhere here, we have the cold sector here. I mean, the cold symbol, the cold front symbol, and the warm front symbol, almost sitting on the same line, which indicates that that is clearly occlusion stage. Okay. Besides that, you also know that we must have discussed this with you learners, or you must be remembering this, that behind the cold front, there is a cold sector, and behind the warm front, there is a warm sector, which simply means that the whole of this sector here, coming this other side, is cold sector. Even if it is not named, but you can know. And the whole of this sector here is warm what? Warm sector. If you remember that evidence also, you can clearly tell the examiner that the cold sector and the warm sector are also existing. Okay, they are also existing. All right. Then besides that, you remember that the system moves from west to east. And when you look at where the cold front is, the cold front is somewhere here on the western side. Maybe it is, that simply means it is proceeding towards this side. And remember we said when you're looking at the characteristics that they move from west to east. Why? Because it is part of the westerly belt. Among other characteristics, you can talk about the date, which clearly indicates that it's winter date because August is not yet summer. Okay, it clearly indicates that we are still in winter time. Okay, so the date indicates that it is a cold front. There are very many things that you can look at. Okay, so you can even look at the rotation. Air rotates anti-clockwise within here, though it's not actually the the air rotates clockwise within the cold front, the mid-latitude cyclone. However, even in tropical cyclone, it rotates clockwise. Therefore, that one, I will definitely say it won't work here. We need the evidence that indicates that this one is truly a mid-latitude cyclone, which is what is unique with it. Don't look at this, what happens with it and also happens with tropical cyclone. It does not give a clear picture of what we want. Hope you understand that. Okay. We'll go ahead and look at question 2. It's a 1 question mark, but I'm taking a little bit of more time because I'm trying to expand and explain more and more, such that in case another question comes and it is on one of the things that I've handled or that I've tackled here, then I definitely know that you won't struggle to answer those questions. Okay. We go to question number 2, 1.3.2. 1.3.2 in says that why does this weather system originate at the polar front? Why is it that, or why does this weather system originate at the polar front? Okay. They're asking, why do you think? We go back to the diagram. Maybe you can clearly get it. Why do you think this system originates at the polar front? Okay. Okay. I hope you understand the question. Why does this weather system originate at the polar front? You know, front is the point where the two air masses of different characteristics do what? Do converge. I think I'm even telling you the answer before. Yeah, I even reached there. They have even you can use reasoning and get the answer there. Here, you're saying, why is it why is the system originate at the polar front? But somewhere here, they have talked about a front. Okay, it's here, and they have talked about a front. What do we know about a front? A front, obviously, is where two air masses of different characteristics do what? Do meet or converge. So first of all, does this weather system originate at the polar front? One of the reasons could be that it's because of convergence of the cold, dry air, which is the polar easterlies, and the warm, moist subtropical air, which is the westerlies. Where do they converge? They converge at the polar front or the subtropical region. That is why it originates from there. Okay. I hope that is very clear, learners. Okay. Then the second question, question number 3, says, give a reason for the direction of the movement of this weather system. Okay. Give a reason for the direction of movement of this weather system. First of all, when I was starting to explain about the mid-latitude cyclone, I hinted on all these ones. I even indicated here that it moves from west to east. And I also gave a reason. You see, learners, why it is very important for you to first study the diagram critically, understand the diagram very well, try to answer it before you see the questions, and that will help you to ease your work when you try to answer the questions. Okay, so we go back and see that you give a reason for the direction. Number 1, it's how many marks? By the way, learners, it's very important to look at the mark allocation. Number 1, that it is driven by the westerly winds. Westerly winds. If I must remind you of this, you remember, if you remember, you would have drawn something like this. Sorry. And then when you divide it like so, this is the equator. Somewhere here, we have what we call the 30, and somewhere here, we have the 60. Then at the end here, we have the 90. Okay, sorry about my pen. So here is where we have the westerly belt. Winds move from west to east. You see that? So if winds are moving this way and the system is within here, automatically that system is also going to be forced to move into that direction. So the reason is that it is being driven, or it is steered by the westerly winds. However, someone can also say that because of its location, look at its location. This belt here is within the westerly belt. This is what we call the westerly belt here. Okay. If this is the westerly belt, how are the winds moving in the westerly belt? They move from east to west, meaning that whatever is here, it's like you sitting in a bus that is going in the west, in the easterly direction or eastward. Automatically, even you who's in that bus, you will go in the same direction where the bus is going. So one of the reasons that you're going to give here is because it is located in the westerly belt. Okay, it is located in the westerly belt. So those are reasons. It is driven by the westerly winds, or it's located in the westerly belt. You can choose any that is answering these questions. Okay, I want to teach my learners nicely and ensure that you get very good marks. So I want you to understand clearly. If there is anything that you're not understanding, please feel free to come in the inbox, ask questions. We'll definitely assist you. We'll definitely answer those questions. All right, we go to the next question. The next question, that is 1.3.4. 1.3.4, it says, it's saying, why is the cold front associated with severe weather condition? We're talking about the cold front, and they're associating the cold front with what? The severe weather conditions. You see that? You see this cold front and the severe weather condition. Why? Why means give reasons. Don't forget the mark allocation. It's 1 times 2. That means it is 1 point. Okay. They're saying, why do you think the cold front? We can quickly go back to the diagram and see which one is the cold front. The cold front is here. But what do we know about this cold front? We all know that warm air from this other side rises or ascends in the upper atmosphere along the cold front, and it results into the development of what? What we call the CB clouds or the cumulonimbus clouds, which we know that these cumulonimbus clouds are associated with the heavy rainfall, okay? Heavy rainfall, thunder and lightning, okay? And so on and so forth. Those are kind of, when you look at that, you're going to see that here, that means along the cold front here, you expect heavy rainfall. That is one of the severe weather conditions. You expect thunders. That's another severe weather condition. You expect lightning. That is another severe weather condition. And so on and so forth. So, under that reason, we need to understand. The question is asking, why do you think it has got that serious weather conditions? Okay. So, by me explaining those aspects before I look at the question, I've already answered the question. Okay. But I also want to answer it the way it is indicated. Though, like I told you, learners, that I'm not specifically looking at the question only. I'm trying to elaborate. I'm trying to explain further about different aspects so that in case it is exam time, you can try to remember some of those aspects that I have explained. One of the reasons that I've indicated here why it would be having severe weather condition is because of the upliftment or the uprising or the rising warm air. That is one. You know that when this warm air rises, if you remember very well in your grade 11, we said that warm air rises, and warm air is associated with the formation of cumulonimbus clouds and so on, and this is associated with unstable weather conditions. You understand? So those unstable weather conditions are clearly indicating automatically what happens along the cold front. So one of the reasons that we are going to have is that there is continuous and rapid rising of warm air along the cold front. And when it rises, it condenses, forming clouds, forming rainfall. So reason number one is the rapid and continuous rising of warm air. So we shall say continuous rising, or we shall say continuous ascending warm air along the cold front, and automatically that will disrupt the weather conditions, and therefore we shall have those severe weather conditions experienced along that cold front. That is number one. Remember, it is 1 times 2. It is 1 mark. Maybe in an exam that you might face, they might say 2 times 2. So I'm going to give you at least 2 points so that you pick up what you feel is easier for you. Okay? Or 1 or 2 or 3, any, fine. So the second reason that I can give is that, first of all, when this warm air rises, what is next? It results into the development of cumulonimbus clouds. So we shall say the development of the cumulonimbus clouds. If you remember very well in your grade 10, you looked at the cumulonimbus clouds. You mentioned some of the characteristics, like what? That cumulonimbus clouds grow very tall, okay? They develop to greater heights. They are flat-bottomed. They grow wider. They are associated with heavy rainfall and so on and so forth. Automatically, because of the excess of cumulonimbus clouds along the cold front, you expect resultant effects of what? Heavy rainfall, okay? Lightning and thunder. All those ones are conditions that are known as severe weather conditions that will be experienced along the cold front. Therefore, we say because of the prevalence of or the existence of the cumulonimbus cloud, automatically it will result into the severe weather conditions along the cold front. Okay, and we also know that along that line there is also what we call the backing of winds. What is backing? Backing is the change in the direction of winds. So we know that because there is continuous rising of warm air, it results into the winds to change directions. And when these winds change direction in the southern hemisphere, we call it what? Backing. Okay, so that is another reason why we shall have the severe weather condition, because the winds would have changed direction. So there will be disruptions along the coast or in the way as they are being formed. All right. We go ahead and look at another question. The next question is 1.3.5. Don't forget the mark allocation. They're saying 1, but I give many because I want you to be in position to get as many points as possible, in that if a question comes and it is 2 times 2, you still don't stress. You have marks to give. Okay. The next one, they say, explain the formation of the stage of development shown in figure 1.3 of the mid-latitude cyclone. Explain the formation. So there we look at what the question requires. The question requires explain the stage of formation. In which stage is it of the MLCs? We're looking at the stages of formation. What are the stages? Remember, I outlined the stages when I was explaining about mid-latitude cyclone, okay? But now when you look at the diagram, do you think that this one is, do you think that, is it an initial stage, a development stage, a mature stage, occlusion stage, or dissipating stage? Let us try to remember some of the characteristics that are there. Initial stage, the pressure is still high. Is this above 1,000 hectopascal? Is this high above 1,000 hectopascal? No. So that means initial stage is out. We look at the development stage. Development stage, we say the pressure starts to drop and a wave develops. That means a wave develops, and that clearly means that the cold front and the warm front are not yet clearly formed, but here they are clearly formed. Therefore, we also take out the development stage. What are we remaining with? We are remaining with the mature stage, occlusion stage, and dissipating stage. And then when you look at the diagram, we have another characteristic, which we know that, another stage, which we know is a mature stage. And when we talk about mature stage, we know that the pressure drops further or drops down. When it drops down, the cold front and the warm fronts are well developed, okay? And if they are well developed, the gradient is very steep, and so on and so forth. But is it that stage of mature? I would say it's not a mature stage, despite the fact that we can see the cold front and the warm front. Why? Because somewhere here along the same line, we have the cold front and the warm front sitting on the same line. Those two symbols, if they're sitting on the same line, we quickly say it is occlusion stage. Automatically, it's not dissipating stage because the pressure has dropped further here. Okay, so this simply means that it's not a mature stage, it is occlusion stage. So the moment you understand that, oh, it's occlusion, sharp, what next? You remember about the occlusion stage. Yeah, things we need to mention about occlusion stage. Like what? The cold air moves faster than the warm air. It catches up with the warm air and it starts eating up the sector that was occupied by the warm air, pushing the warm air outside the cyclone, and this results into the development of what we call the warm occlusion and the cold occlusion. Okay, so the moment we talk about those aspects, guys, you can understand. Okay, you can understand what I mean. So, under that line, we understand that this is occlusion stage. So we need to know if we say that it's occlusion stage, we go back to the question. Let's see the question. That was the first thing that I wanted us to know. So if it is occlusion stage, what do we need to know? Occlusion stage, we need to understand that because they are saying explain the formation of the stage, so we need to explain how this stage forms. Okay, the first thing first, we are going to mention about number one, cold air moves faster than warm air. Okay, cold air moves faster than warm air. So if cold air is moving faster than warm air, okay, what happens? We can explain the second point. We are going to find out that if cold air is moving faster than warm air, so warm air catches up with, sorry, it's not warm air. Cold air catches up with warm air, narrowing the space that was occupied by the warm sector. Okay, pushing it outside the what? The cyclone. What does it mean? You'll find out that if this is the cold sector, and this is the cold front, and this is the warm front. This one is moving faster. That means it is catching up with the warm sector. And the warm sector has got the warm air. So it's pushing the warm air outside the cyclone. Do you see that along this front, we shall develop two symbols because there is a cold front and the warm front that is developing along the same line. Therefore, we shall come up with what we call the occluded stage or the occluded front along this line. So we are going to say that warm air moves faster. Cold air moves faster than the warm air. And when cold air moves faster than the warm air, so that means the cold air is going to catch up with The cold air is going to catch up with the warm air, narrowing the warm sector, pushing the cold air, pushing the warm air outside the what? Outside the cyclone. Okay. You understand? And therefore, when it pushes it outside the cyclone, what will happen? Simply means that at the apex, okay, at the apex, the cold front, the occlusion front is going to do what? It's going to develop. And when it develops, obviously, we are explaining the occlusion stage. And therefore, you'll get all your marks along that line. Okay. We look at the next question. We look at the next question. The next question, sorry for that. The next question says, why? See, I read as many times as possible. Why? Why does the cold front of the mid-latitude cyclone have a positive impact? The question is asked, why? Give reasons. Why does the cold front of the mid-latitude cyclone have positive impact? Positive. The question is one-sided. Positive impact on agricultural activities in Western Cape. Positive. We are focusing on positives only. And the question is asking why. That means we are basically going to give the reasons as to why we shall have a positive impact on the other side. Okay. Okay. We're talking about the cold front. What do we know about the cold front? We know that the cold front, number one, it is associated with heavy rainfall. And how will this be important? Heavy rainfall will fill up the dams, okay, that they will use to water. In case of a dry period, they will use this to water the farms. And if they water the farms, it obviously means that the agricultural activity has got a positive impact. So do you see the reason why? The reason is why do we have such? Because we shall have heavy rainfall that is associated with the cold front. Remember, the question is asking why. So since the question is asking why, that means you need to give reasons why we shall have a positive impact. One reason is that this cold front has got heavy rainfall. So because it has got heavy rainfall, this heavy rainfall will be very important. How? It will be important in many ways. Number one, it will fill the dams. Number two, it will make the rivers full. Okay, that means the rivers will have water. Number three, besides the rivers having water, people might have their tanks, like JoJo tanks, that will also be full. But in case of anything, they will need to use water and there is no rainfall. They can easily have access from the dams, from the JoJo tanks, from the rivers, and that will assist them to water crops. And by watering crops, it simply means that there will be a positive impact on agriculture in Western Cape. Okay, that is number one. Reason number two that we can give, we can also say that because of rainfall still, people will be in position to water their crops. The first reason was they will be in position to have water in the dams that they will use in the later stage. The second reason is that besides them having water to use, they will have water to irrigate the crops. And by them having water to irrigate the crops, it simply means agricultural activities are going to benefit. See that? So the agriculture sector will benefit because there will be enough water that will be used in the watering of the crops. When we talk about watering, we are basically referring to irrigating of the crops. Okay, I think you see how the agricultural activities are benefiting from the cold front, okay, in Western Cape. We also look at the fact that the agricultural activities in Western Cape are also going to benefit. How? In the same line that if water is available, crops will grow. What will happen? That means agro-based industries are going to benefit as well in Western Cape because there will be continuous supply of agricultural crops that will be used as a raw material in the agro-based industries in Western Cape. You see how the agricultural activities are now being assisted, or how these people are benefiting from that aspect. We also look at another aspect. We can give as many points as possible. We know that we all irrigate crops, or besides that, we can use pesticides, we can use insecticides to kill insects that are affecting crops. That means the soils will have those kind of chemicals that are remaining within that region. But when it rains from the cold front, we shall have enough rainfall, and this rainfall will wash away all those toxic um, uh, um, toxic materials or elements that would have affected agriculture in the long run. And you see that the agriculture activity is now benefiting. So that means it cleans the polluted rivers, or it cleans the polluted environment. And that means even the water that is going to come to the agricultural products, or to the agricultural to the crops, is going to be clean water. Why? Because the cold front has got rainfall. Do you see how this is very important? Do you see how that is very important? We can also look at it in a positive way, that when it rains, yes, it results into flooding. But what is important with flooding? Flooding will mean that some topsoil will be eroded and deposited somewhere. And maybe that soil that is deposited somewhere can be used for agriculture. Do you see that? So it simply means that soil fertility will be improved under that line. So improving soil fertility, how is it important? This will assist in favoring the growing of crops in Western Cape. And how is it coming about? It comes about because when it rains, flooding will take place, fertile soils will be deposited somewhere that can be used by agriculturists to benefit. Okay, do you understand that? I hope you understand. I hope we are all at the same page. Okay. So besides, when you're talking about agriculture, I don't want you learners to be one-sided. Agriculture simply means the growing of crops, rearing of animals, and poultry. When you talk about poultry, sorry, when you talk about crops, that means you're looking at basically arable farming. Then you talk about animals, that is livestock. Then you talk about the keeping of birds, okay, that is poultry now, keeping of birds and so on. So don't be one-sided only looking at the crops. You can also look at animals. How do animals benefit? That when it rains, the grass will grow for animals to survive on. That is benefiting agriculture activities. Besides that, when it rains, water will be available that will be used to feed the or to drink by the animals. Do you see that when animals are now also benefiting under that line, it is assisting what we call it will be assisting the agriculture activities, and which is what we call the positive impact on agricultural activities. You understand that? I hope it is very clear. Eh? I think it is very, very clear, learners. So at least today, I managed to go through that question of mid-latitude cyclone. Okay. Next time, I'll also pose another question of tropical cyclone, and we see how we can answer also that question. Because at least if I can do one, and in that case, I finish that one and you understand it clearly, then it will be okay. If not, I can also pose another question. I can bring another question regarding mid-latitude cyclone. So you will find out that most of these questions are almost the same. Okay, so this will assist you to know that, oh, there's no very big difference. So if you understand your question nicely, you won't face any challenges. Okay. I want to look at this question here. I want to look at this question here, which is 2.1, 2.3, figure 2.3. Okay, let me check with the annexed learners so that we can see what 2.3 is talking about. Okay, 2.3 is there. Let us look at this diagram, 2.3. Remember, I told you that we don't need to go and read the questions first. We need to, first of all, understand, study the diagram. That's why they say refer to figure. Reason why they say refer to figure A, figure B, 1.2, 1.3, they're trying to make sure that you study the diagram nicely. Hope you can see this diagram, learners. When you look at it, it says 2 stages of development of mid-latitude cyclone. What do you see? We see there is this stage and there is this stage. They are saying 2 stages. By saying 2 stages here, né? By saying 2 stages here, that means you are going to see which stage is it. You remember when you're looking at stages, we said that we can have a cold front and a warm front existing, but it does not necessarily mean that it's a mature stage or occlusion stage. We need to look at other critical things. So when you look at this one, at the pressure has dropped further. We are now studying the diagram. The pressure has dropped below 998 hectopascal. Okay, but when you look at this one, the pressure is 1,000. That means somewhere above this stage, it's not the same like here. So what do we see? We can see a well-developed warm sector, a well-developed cold sector, a well-developed cold front, a well-developed warm front. The pressure has dropped further. The spinning of the wind around the low pressure is clockwise. Okay, so this is southern hemisphere. And when you look at this stage, it clearly indicates that A is a mature stage. That is obvious. When you come to this, you would see that, yes, there is a warm sector, it is a cold sector, but along this line here, there are 2 symbols existing. And what did I tell you? That if you have 2 symbols sitting on the same line, it clearly indicates that it's an occluded front. And this is occlusion stage. Okay? So, and you can see that within the occlusion stage, the pressure starts to rise again. Do you understand that, learners? So when you study this diagram, you will know that at least stage A is mature, stage B is occlusion. Okay. Before you look at the questions, you have already answered the questions before you even see them. Do you understand that? This makes geography very interesting. Let's see the questions now. Okay. Figure 2.3, which shows 2 stages in the development of a mid-latitude cyclone. Okay, 2.31. It says, state the hemisphere. Is it north or south in which the mid-latitude cyclone is developed? What do we look at to say whether it's south? And you remember, I even answered that question before I could see the questions, because I told you that if you see you see the symbols, the rotation here. First of all, let us look at the rotation of A. The A rotates clockwise. Okay? And if A rotates clockwise, the same here, it indicates that it is southern hemisphere. If you can remember this hint here, I told you, you draw your letter S. When you cut it into 2, you say north and south. In the northern hemisphere, you can see it's a low pressure, but it is anti-clockwise. When you cross the equator, it starts moving clockwise. You see that? So this is clockwise, this is anti-clockwise. If you can remember this, you won't forget the spinning of A around the rope or into the low pressure. You won't struggle, learners. So we have answered this. Which other evidence can we see that it is southern hemisphere? We look at the warm sector. Look at the warm sector. The warm sector is facing northwards. The same way here, the warm sector is facing northwards. And the cold sector is facing southwards. The cold sector is facing southwards. You remember, you also go back and remember, if you are confused, you remember this. And this is the equator, okay? This is the northern hemisphere, this is southern hemisphere. If you draw this line here, I'll name it 60 degrees. And this way somewhere here is 30 and 90. Do you know that the A that leaves the polar front is called polar easterlies, okay? Polar easterlies. So they will be like this. So if this is polar eastern and we know it's cold, the cold sector will be in the north if it's the northern hemisphere. Come to the southern hemisphere. This is 90, 60, and 30 here. What do we see? We know that somewhere here is the pole, which we know that the South Pole. And the winds that leave the southern, the pole, we call them polar winds. But because they appear to be coming from the eastern side, we call them polar easterlies. So they come from this side to this other side. Do you see that? So we call them polar what? Polar easterlies. So if you look at this, if this side at the bottom here is where we have the cold air concentrating, it indicates that it is cold sector in the south. So cold air is in the south. You can see that means the cold sector is going to be in the south. You can see it. And here we shall have the subtropical westerlies or the westerly winds that are in the north. That means the upper part is going to be warmer. So here is warm, here is warm, here is cold, here is cold, which indicates that southern hemisphere. So we have as many evidences as possible that you can use to answer this question. But given the fact that they just want one answer, which is in state, whether it's north or south, when you go back and interpret the diagram, it indicates that this is the southern hemisphere. Therefore, it's south where this mid-latitude cyclone has done what? Has developed. Hope it is clear that way, learners. Okay. Let's go on and we'll look at the next question. Give reason for your answer. You see that by reading the diagram, you already have the answers. The reasons are there. We talked about the spinning of A, which is clockwise. A rotates clockwise. The warm sector is facing northwards. The cold sector is facing southwards. All these ones, the rotation of air is clockwise. All these ones are evidence that indicates that indeed this is what? Southern hemisphere. Okay. That indeed this is southern hemisphere. So let us go quickly and look at the next question because there's no further explanation that you need. Okay. So we can go put evidences there. What evidence can we have? Clockwise rotation. Remember, it is 1 mark. So you can use any point, clockwise rotation. Then you talk about the positioning of the cold sector and the positioning of the warm sector and the cold sector. So you say the warm sector faces northwards, or the warm sector faces northwards, okay, or lies in the north. And therefore the cold sector also, for it lies in the south. Okay. You can also look at where the symbols are facing, which implies the rotation. Okay, so any evidence that you give is fine. Let us go on. Along which front does the mid-latitude cyclone develop? Along which front does? I explained this, learners. We have answered it it was in the other question. It is what you call the polar front. Okay, it's the polar front. Okay, the next question is that the one difference between the cold sector and the warm sector. Just one difference. So when you are stating the difference, you make sure that it is different. What do we say? We shall say, if it's cold sector, do you expect air to be warm or cold? Automatically, it will be cold. Therefore, we shall say, cold sector, air is cold, while, remember, it's state difference, while warm sector, air is warm. That is one difference. So those are the first 2 marks. The second 2 marks, we shall say that within the cold sector, if it's cold air, what do you know about cold air? If you remember the characteristics of cold air in your grade 11, we said cold air is dense. Therefore, we shall say within the cold air, the cold sector, within the cold sector, the air is dense, heavy or heavy and dense, while here in the warm sector, it's going to be light. Okay, it will be light or less dense. Is it okay? You can also give another characteristic and you say, because here is cold air, what do we know about cold air? Cold air results into high pressure. Therefore, we shall say within the cold sector, there is a high pressure. But within the warm sector, there will be a low pressure. You can have as many differences as you can. Okay. But those are enough for us to proceed. So let us proceed because we need to, it's just 2 marks. So you choose. But when you're giving difference, you make sure that you state it complete. Okay. It's a difference. So if here is red, then you say the other one is blue or black or whatever. So cold air, in the cold sector, air is warm. So what about the warm sector? The warm sector, air is, sorry. In the cold sector, air is cold, while in the warm sector, air is warm. That is the difference. Okay. All right. Let's go to 2.35. Describe how occlusion stage occurs. Do you see that now this question looks similar? Like this question we answered here. See, this one was saying, explain the formation of the stage of development shown in the Latitude cyclone, which we say that the stage was called was occlusion stage. And then when you look at this question is saying, describe how occlusion stage occurs. You see that the question is now, it's just the way it is twisted, but it is the same question. It is answered the same way. How? You're going to say cold air moves faster than the warm air. Okay. Cold air moves faster than the warm air. So what happens? So the cold air wedges underneath or cuts underneath, okay, underneath the warm air, lifting it outside, wedges underneath the cold air, lifting it outside the cyclone. And what happens at the apex? Okay, we shall have the two symbols sitting or appearing, which results into the occlusion stage. So you can see, learners, that this is the same what? The same way the question was asked. So I won't dwell more. I won't take more time there. The last question says that explain why it is suitable for outdoor activities to take place after the occlusion stage. It says after. What does it mean? After the occlusion stage. We have just said that the occlusion stage, the pressure goes high, you know. We also know that within the mature stage, what are some of the conditions that might prevent people from having their activities outside? Okay, that now will be different from that will be different in the after the occlusion. Okay, so you look at those aspects. Why do you think we shall have outdoor activities? What do you understand, learners? We say outdoor activities, meaning that the activities that are outside, when you're outside, will it take place after the occlusion? Yes. Why? Because after the occlusion, we do not experience that kind of heavy rainfall. So that means no rainfall will be existing. Okay, no rainfall will be existing to disrupt the activities, the outdoor activities. That's why we shall have outdoor activities more pronounced or more dominant after the occlusion stage. That is number one. Number two, you can also say that after the occlusion stage, the weather will be stable. Remember, we say that the pressure goes high again after the occlusion stage. If the pressure goes high again, that means cold air will be existing. So the weather conditions will be stable. So we shall experience what we call stable weather conditions after the occlusion stage. And that will assist us to have outdoor activities. If the weather conditions are stable, you expect the winds to be calm, clouds to be clear, and that will favor outdoor activities. Okay. Besides that, after the occlusion, the temperatures won't be very cold. So we shall have mild temperatures, mild temperatures existing. And when we talk about mild temperatures, we're talking about mild, meaning it's so cold, it's not so cold, it's not so hot. And those temperatures are favorable for the outdoor activities to take place. So mild temperatures will be existing, mild or moderate, okay? Or moderate. So it won't be cold, it won't be hot. That will favor activities to take place, okay? What about the winds? The winds will be calm, calm winds. So if the speed is not that rapid, it simply means if you want to put your tent outside, you want to have your braai outside, your activities will be going on very well. Okay, because it's after the occlusion, the conditions are calm, and so on and so forth. Okay, I would love to stop here today, learners. Hope you have enjoyed the lesson, and I hope that you can ask questions where you're not understanding, such that we will be in position to assist you and you get everything done. Okay, so see you next time. Bye-bye.